Chapter 16, Part 3, Heat Transfer, Radiation. Radiation is the third method of heat transfer. In radiation, heat transmitted or transferred in the form of radiation energy or electromagnetic waves. Let's start by asking the question, how does the sun warm Earth's surface? Well, it cannot be through conduction or convection because there is nothing between Earth and the sun. It's just pure space. So the method of heat transfer in this case is radiation. Radiation comes to us from the sun through electromagnetic waves. Now, electromagnetic waves comprises several types of waves. Let's arrange them from the longest wavelength to the shortest, starting from radio waves, microwaves, infrared waves, visible light, that's the light we see with our eyes, ultraviolet waves, X-rays, and finally gamma rays. Examples: radio waves send signals through the air and empty space. We feel heat in the form of infrared waves. Visible light is also a form of radiation energy. Now, most of the heat from a fireplace goes up the chimney through convection. However, some of the heat will come to us through radiation. Emission of radiation energy. So some objects, well, in fact, all objects, they emit radiation energy. Now, objects at low temperatures, they emit longer waves. However, higher temperature objects, hot objects, they emit waves of shorter wavelengths. So objects around us emit radiation, mostly in the long wavelength end of the infrared region, between radio and light waves. Shorter wavelength infrared waves are absorbed by our skin, and this will produce the sensation of heat. So we feel hot, okay, because we are absorbing shorter wavelength of the infrared waves. So heat radiation is infrared radiation. People with the surface temperature of 37 degrees Celsius, our body temperature, they emit light in the low frequency infrared part of the spectrum. Very hot objects emit radiation energy in the range of visible light. At 500 degrees Celsius, an object emits red light. Longest waves we can see. Higher temperature will produce a yellowish light. At about 1500 degrees Celsius, all the waves to which the eye is sensitive are emitted, and we see an object as white hot because we are seeing all the visible waves. Now, the surface of the sun has a high temperature, 5500 degrees Celsius. The surface of the sun will emit radiation energy at high frequency, much of it in the visible portion of the electromagnetic spectrum. The surface of Earth, by comparison, is cool, and the radiation energy emitted by the surface of Earth consists of a frequency of low frequency than the visible light. Question: why is it that light radiated by the sun is yellowish, but light radiated by Earth is infrared? Well, the answer is easy. The sun has higher temperature than Earth, but Earth radiates in the infrared because its temperature is low compared to the sun. Another question: if everything is emitting energy, so why doesn't everything finally run out of it? Well, because not only objects emit energy, radiation energy, but they also absorb energy from the environment. So we have a very important topic to talk about: absorption and reflection. Of course, absorption and reflection are opposite processes. A good absorber of radiation energy reflects very little radiation energy. A good absorber, therefore, appears dark because it does not reflect much energy. A perfect absorber reflects no radiation energy and therefore it appears perfectly black. Good reflectors, on the other hand, are poor absorbers. Light-colored objects reflect more light and heat than dark-colored ones. In summer, you know that light-colored clothing keeps people cooler because they reflect much of the heat and light. Anything with a mirror-like surface reflects most of the radiation energy it encounters. So it is a poor absorber of radiation energy. On a sunny day, Earth's surface is a net absorber. However, at night, Earth's surface is a net emitter. It emits energy, thermal energy through radiation. On nights without clouds, cloudless nights, the surrounding of the Earth are the very cold depths of space, and therefore cooling of Earth is faster than on a cloudy night. In fact, record-breaking cold nights occur when the skies are clear because cooling is faster.